Hi there to everyone logging in. We're just going to give it probably another 40 seconds here. If we make it to 2 o'clock, give people a few more minutes or a few more seconds to join. If you don't mind keeping yourself muted for the beginning part of this session, and then we'll let you know when we get to the open section. Okay, well, I have 2 p.m. on. Hello and welcome, everyone. I'm Sam. I'm helping out just kick things off today. You might have recognized me from previous ACG webinars that I've moderated in the past. Welcome to the first Commissioning Spotlight series. Thrilled to have you here and excited about this new format. Just to restate the new format of this session, the first 15 to 20 minutes will be our expert presenting, followed by about 40 minutes of a Q&A session and discussion. We want this to be as engaging and interactive as possible, so please don't be shy. Everyone does have the ability to speak if you do unmute yourself. And once we get into that section, we can do a deep dive into the topic, and please be ready with any questions that you have. So we're going to be talking about short circuit coordination and arc flash report today. I have Derek on with me today. He's the ACG Education Committee Chair. He's an expert in medium voltage power systems, life safety, lighting control, security systems, power distribution, and emergency power systems. And he has extensive field and on-site experience and knowledge of mechanical and control systems required for validation and integration of multidisciplinary systems. So he's perfectly suited for this topic. I'm going to hand it off to him and we can kick off the first half of this session. Derek?
Great, thanks, Sam. Hi, everyone. This is a new format for ACG, and you're very familiar with the webinars that we've been promoting and publishing, and those are a little less interactive. And we felt going into 2023, we would like to offer the membership an opportunity to actually have a live Q&A session on a very targeted topic where we're hoping to draw interest throughout the year from experts within our industry as well as within our association. And I figured since I was going to volunteer the topic, I should probably volunteer myself to go first. And this topic is very near and dear to my heart, as it probably is most of you, because as a commissioning agent or as a building owner, sometimes we don't know exactly what we're supposed to be doing with these reports. So I wanted to really try to dissect our scope of work for commissioning when it comes to a short circuit coordination and an arc flash report. So with that, I only have about 10 slides, and this will be very free flowing. Feel free to use the chat feature within Zoom, and you can just pose your questions in there, or you can go off mute and we can actually have a conversation. I want this to be very, very open. I'm not claiming, I appreciate Sam claiming that I'm an expert in all these fields. I am like you, I'm also still learning, and I'm learning many things about things that I've known about for much time. And short circuit arc flash and coordination studies is one of those that if you don't dive into it all the time, you're bound to forget something. So this is preparing for this presentation actually gave me an opportunity to do some research and some homework to really freshen up some of the areas that I was questioning. And a lot of that had to do with actually around arc flash. And we're going to cover arc flash towards the end here. But let's get going into this. So what is our goal today? What our goals are to have a commissioning focused discussion around the SCCAF report. So first off, we're going to introduce what does SCCAF even mean, SCCAF. And then we're going to talk about at the end, what is a commissioning authority's scope related to this report. Now, if you were calling in and hoping I was going to dive into the many softwares that are out there with ETAP or Power Tools for Windows, I am sorry, I am not going to do that. Having a 1-hour session on what it takes to actually build a short circuit study would not do that service. Short circuit studies are very complex, and there's a lot of engineering that goes into that, and I don't think we could cover in 1 hour. That might be a good future topic for another day, but I wanted to take this deliverable, take this very important safety document and dissect it so that we as commissioning agents understand how it affects our scope and what we should be doing to serve our owners when we get these documents. So let's start with some definitions. This is an acronym that if you Google it on the internet, you may not come across it. You might actually see something called a coordination study or a short circuit study or an arc flash hazard analysis. Well, all of those documents make up a SCCAF report. The short circuit, the coordination, and arc flash analysis come out of a requirement in the contract documents. Division 26-0573 likely is also called the power systems study. It can be developed by the engineer of record, perhaps an owner that has very knowledgeable engineers on staff and has the tools that they've invested in. More than likely, though, it comes down to the manufacturer of the equipment or the electrical contractor that are required to develop those studies. Now, why do we develop these studies? Well, one, we develop them because code NFPA 70E, as well as OSHA, require that this analysis and study be performed for your project. But for an owner, for reliability and resiliency, you want to ensure that all of the overcurrent protection devices are properly coordinated so that when you have a short circuit fault downstream, like on a panel board, or you have a phase fault on a conductor, you're not going to trip your main incoming breaker, right? You want to trip the next available overcurrent protection device. So you want to keep your system up and running. And that's why you do a short circuit study analysis. And that rolls into the coordination study for setting your breakers, which is then combined, and then you get an arc flash hazard analysis. So the short circuit study, it looks at the full circuit of your system from your utility feeds all the way down to your largest motors, your transformers, your feeder panels, to ensure that if you have a fault, your devices will properly be staged and staggered, that you're tripping the first available overcurrent protection device, right? You're trying to prevent a large loss of damage to equipment and obviously to people, right? Personnel and safety. That's why the SCCAF report is really an EH&S tool. It's really a tool that the operations and maintenance team need to have readily available so that they can reference it as they're looking at their infrastructure, but also if they make modifications to their infrastructure, they have this report, not just the physical PDF copy, but also the electronic files that go along with it that they can be modified. So we'll get into that a little bit later. I just wanted to give you quick brevity as to what the short circuit side looks like. So using the short circuit side, you're going to have all of your devices modeled, your breakers, your relays, your fuses. And then typically right around chapter 4 of the power system study, you're going to have the coordination table. The coordination table is going to look very similar to what you have on your screen, where you're going to have your devices called out on the left, followed by the manufacturer, the model of that device, the current rating, as well as any other available settings that need to be provided. This table that you see on the screen is actually for medium voltage relaying. So you can see it covers overcurrent relay 51 and 50. You would also have breakers provided on here as well. But this is important for us when we get into our scope discussion as to what it takes to properly set these devices and then validate that they indeed work as intended. The last part brings together the short circuit study analysis and the coordination table into the arc flash hazard analysis. So this is the part that's also required by NFPA 70E, because this generates what everyone's very familiar with on the screen is the arc flash label. The arc flash label is applied to the front facing or sometimes the rear access of equipment, panel boards, switch gear, covers. They will then have in this table a lot of information that pertains to you as a commissioning agent that you need to be aware of. The first I'm going to highlight is the incident energy available for that piece of equipment at that device. The second is the arc flash boundary. Arc flash boundary, what we're trying to determine there is the distance away from an arc flash where someone would be able to receive a 2nd degree burn. Now, this doesn't mean you need to stay 21 feet away or 31 feet away, but when you are working within that equipment or near that equipment and you wear that proper PPE, you are within that arc flash boundary. There are other boundaries listed on here as well, such as the working distance, such as the gap required between equipment and phases. So there are different ratings and different requirements on this table, but I just highlighted the first two that really pertain to anyone that works in or around an electrical room that's energized, specifically in a construction environment where you have many trades meandering in and through an electrical room or near a transformer vault where there could be an arc flash hazard. You want to make sure people are wearing the proper PPE as required by the arc flash label. We'll get into the nuance of how this gets applied in just a second. But so far we've covered the basics of the short circuit study, the coordination, and the arc flash hazard. Okay, so now let's talk about our scope, right? We understand there's a document that's developed based on the contract specifications, but how does that affect me as a commissioning agent? What if my scope doesn't even have electrical commissioning in there? Well, it still affects you because obviously safety is always first on our project sites. So if you are commissioning mechanical equipment, they have to energize the breaker for your device or for your equipment, which is fed from a panel board. So you want to make sure that we have a lockout tagout plan first and foremost, but also once they energize that equipment, we have an arc flash label. Now, the arc flash labels are always a challenge to get into a project during construction. I understand that, as many of us do. So contractors typically will work within and under a temporary arc flash label, which will carry bare minimum requirements for PPE, but also it'll carry the requirements that only the electrician and or qualified staff can enter and work within that space. So let's take a pause there. You, as the commissioning agent, working on a mechanical piece of equipment that serves an electrical room, need to be aware that if you're working in or around that electrical vault or that electrical room that is energized, you should also be wearing or be prepared to wear that PPE if people are working in that electrical equipment, right? So you need to make sure you're wearing and keeping safe distance away such that you can do your job safely. Because, as we just mentioned, all of your scope is fed from electrical equipment. So all of those sources should have an arc flash label and should be properly coordinated via that SCCAF report. So the breaker settings will be verified, and we'll talk about how that's done in a little bit. Arc flash labels are applied, and we'll talk about what happens if those get changed, because those reports likely will go through multiple revisions on a project. If those are revised, new settings will be provided, as well as new labels will need to be affixed. And also, you want to help ensure communication is followed on the project site, right? You want the general contractor and the electrical contractor to be communicating on what circuits are energized, what spaces and rooms have potential voltage for your team to be safe and be aware. So that's the bare minimum scope that you should be involved with. So what to look for? What to look for in this report? So now you're not necessarily just commissioning a mechanical piece of equipment, going to look at the SCCAF report. I understand that you're just going to be looking for the arc flash label, verifying that your equipment is being fed. But if you do have electrical commissioning as part of your scope, you want to treat the SCCAF report much like you would a tab report or a NETA testing report. right? It should be an accurately defined document with the project title. Revision history should be tracked. Who developed it and what software they used to develop this report. A table of contents that outlines the material behind it. An executive summary and one-line diagrams, as well as applicable time current curves and device coordination tables. So who sets those overcurrent devices? Well, this is a great mystery on some projects because a lot of times people will point fingers at one another. You will sometimes see NETA testing agents who are going to set those on behalf of the installing contractor. Sometimes the installing contractor will do it. Otherwise, the owner might hire you as the commissioning agent or bring the engineer of record out to set those devices. So if it's not very clear in the specifications, this is an opportunity for you during your design review scope to ask that question. And we'll get into other aspects of that as well. So just finishing up this slide deck, and then we'll open it up for some Q&A as well as some general discussion. What are some key takeaways, right? So SCCAF studies do not eliminate risk, right? We need to understand that they identify them and provide appropriate safety protocols to meet government standards and ensure personnel and equipment safety. I can't emphasize this enough. A SCCAF report is as much a safety document as it is a functional resiliency document used by the project. You as the CxAs should engage to ensure a smoother and safer energization of equipment. What does that mean? Well, during construction, contractors are always pressing to energize equipment so they can continue to move the project forward. They want to energize a panel. They want to energize a transformer. They want to energize mechanical equipment so they can move on. But realistically, they need to make sure that they have the SCCAF report developed and applied before they do those steps, right? Awareness of what the SCCAF report does and provides is in everybody's best interest, including the owner operator of this facility. But it ensures safety all the way down to the installing trades during a construction project. Additionally, in the specification for developing a power study, there will be incremental milestones that should be followed. Usually a draft report is issued to ensure we have the right software, the right qualifications of the individual or company developing the report. A second draft should be issued, ensuring that we have the proper coordination of all the devices and of all the equipment. And then a final study comes out at the end of the project to capture any changes or challenges, such as equipment feeder lengths have changed, model numbers of breakers were replaced, so they had to get different breakers. So the final study, and this should be tracked in Procore or ACC or whatever tool they're using, should track all of those revisions. And the owner then has this file at the end of the day. I've also offered some great links. If you Google any of these topics, you'll see that a lot of our vendors that provide electrical equipment, such as Eaton or Schweitzer Relays, provide great white papers and great information for you to sit back and read and take in outside of this presentation as well. And I've also included the IEEE standard for the short circuit analysis. So I got one more slide and we'll turn it back over to Sam, and then we'll open it up for some Q&A as well as some general discussion. Or Sam, you just want to talk at the end? She might just want to talk at the end.
Probably at the end. I don't want to interrupt.
Yeah, no worries. So with that, I would like to get into some of the lessons learned I've gone through when it comes to being a commissioning agent in design phase, things I want to look for and things I should be looking for. And then just open it up to you to ask me some general questions that you might have that you've seen. The first thing that I always reference when I do a design review is I start with the one lines, right? I start with the electrical one lines and I start to look at the pieces of equipment that we have. I'm verifying breaker sizing. I'm looking for characteristics such as long time, short time, instantaneous ground fault. I'm looking at relays. And then I jump into the power study spec. I want to make sure that we have those milestones that we just talked about applied. And that's usually applied in part one under the submittal, right? So if I go back a few slides to this here, under part 1 of that specification for the submittal, they should list out all of those incremental submissions so everybody can participate in reviewing it. The most important activity in my mind is getting the study prior to doing the META testing. And that should be called out in the specifications as a design review comment if it's not already there. And the reason you want that is because this is an opportunity for you and the contractor to save time, right? They can set the breaker correctly, the relay correctly, test it for that setting, verify it against the time current curve for that device, and validate its accuracy once and for all. Now, if we don't have the SCCAF report at that time, we might have to do multiple tests. We might have to test it at the low value and a high value so that when we do get the study, we just set it and hopefully it falls within that curve. Or we might have to do something that's called secondary injection testing as opposed to primary injection testing to validate that the trip functionality of that solid state device still works. So design reviews, as we always talk about in commissioning, is the most important time for us to add value. We also want to make sure we're looking at this specification at that point. So with that, I'll open it up to any general questions or comments as we continue our discussion. We have about 40 minutes. So yeah, I will look in the chat window or you can go off mute and ask any questions. Otherwise, I can just keep talking all day. Okay, so another opportunity for validating the SCCAF study accuracy is that something called factory witness testing or integrator witness testing. A lot of times you'll hear contractors testing breakers in the field, right, at the project site, and there's reasons for that. Jostling or handling of equipment, the breaker could get damaged as it gets shipped from the factory to the site, and they want to test it once. They want to make sure it works. But there is an opportunity at the factory or at the integrator to take that SCCAF study and validate we have the actual model, manufacturer, and frame rating correctly. And the reason I bring that up, why that's very important, is because everything is modeled in the short circuit study as well as the coordination table based on the manufacturer providing that right piece of equipment. So if that equipment is wrong at the factory, or if it's wrong at the integrator, that whole study needs to be remodeled and redone. So you as a commissioning agent, if you're doing factory witness testing of switchgear or of a generator, you should have a draft or at least a preliminary review of the SCCAF report with you so you can validate that manufacturer model serial number. And that is right here. I'm just going to draw on my screen so everybody can see it. Right, so that is usually provided right here, but there's other things that you can validate as well, right? The CT ratios, you can validate if this was a breaker, you'd see frame sizing, you'd also see the plug rating as well. So there are other things that you could validate on the table just to make sure that the study has a good fundamental baseline. Now, some contractors will require the factory to test those breakers, but we should always advocate for the owner that we test at least a sampling, if not all, the breakers on site. There is a time saving as to doing them at the integrator as opposed to the site. And sometimes you just have to take what you get, right? Any other questions right now that you want to talk about? All right, here we go. Maybe call on people directly to ask wisdom. Ooh, so Sam wants me to call people out. I don't know. Okay, good. Tom, you jumped up to the table here. Good job. Can you discuss breaker ratings and series ratings? Recently run into some issues when ABB bought GE. GE breakers are currently not series rated and with ABB upstream. Yeah, so what you're probably talking about is you're talking about the series, the short circuit coordination rating of the gear. And what that gets into is back on this table here, where you have the short circuit rating of that equipment and the device that sits within that equipment. Most of your like incoming gear will be either like 100K AIC or perhaps 65K AIC rated gear. What that means is that gear, and I think it says it actually right here, are to ensure that the existing equipment ratings are adequate to withstand the available short circuit energy available, right? So that's the gear. And I think what we're talking about here with Tom is that we're talking about the breakers and the devices within that gear are also rated accurately to serve those loads within that space, within that piece of equipment. One thing that we also mention when we're in the field or in a project, and actually we just ran into this today, is incremental energizations, right? Perhaps a contractor just wants to energize an incoming line switch that feeds a transformer, feeds a breaker, but they're not going to close in on that breaker right away. You should still have a SCCAF study and a SCCAF report available for you and for the team to review, even if they are going to do incremental energizations. The contractor will have chain of custody of those locks and of that room, but from a short circuit study validation, we want to make sure that it's properly modeled before we close in on breakers through transformers as well. Arc flash labels for any piece of equipment that's energized, right? Any piece of equipment that you have on a project, whether it's in construction or permanently handed over, should have an arc flash label on it. The challenge also gets to where owners need this for operations and maintenance. And if you start looking around at the different PPE requirements, they're very expensive. I think like a 65K rated suit can cost up to like $3,000. Now, you as a commissioning agent shouldn't necessarily have to invest into that cost, but you should be aware of the available arc flash in that space so that you can keep your distance and stay away. I remember we were doing a switchgear vault, and Eaton had their suit on, and I was standing good 50 feet away while they did their work. And our vendors provide things called chicken switches, or they might have an HMI panel where the owner can activate a breaker so that they can maintain a distance from that piece of equipment, right? So there are pieces of equipment that come with accessories to help owners maintain distances without having to invest in large, rarely used PPE pieces of equipment. And that's something that you could look for during your design review. Are the accessories available to the owner? Here's one from Kurt. Have you found that third-party development of the SCCAF study falls short versus one done by the EOR? Yes, and I've actually seen sometimes that the EOR studies aren't that good either. Actually, I just got off of a project call recently where the vendor developed the SCCAF study, the EOR stamped it and approved it, and our team, the owner's team, was actually looking at trying to reduce down that incident energy and the arc flash boundaries by tweaking some of those settings. So we have to validate, and this is a good point by Kurt, is that our engineers of record have the time within their contracts to support accurate development and validation of these studies, and not just reviewing it to make sure that they've got the fundamentals, right? We have the curves, we have the tables, and we have the labels. We need to make sure that the owner is actually able to function within this arc flash label or within this study. So having the tools, power tools for Windows or ETAP, SCCAM, are expensive. And I don't always necessarily think we as commissioning agents need to be developing these studies. But if you're working at a company that's large enough and you have these tools available, it can sometimes be a service that your company offers to an owner or to the contractor to develop these reports. Now, I'm not going to say that ours would be better than others, but there is definitely that understanding of how you can mitigate and reduce down incident energy and arc flash boundaries that takes that engineering mindset. We have a guy in our office that came from Schweitzer Relays, and all he did at Schweitzer was develop these studies. So he's our resident genius. And whenever we have a study for a project, we go to him, he reviews it, and he provides us great insight as to the challenges to achieving that. Next one, as a note to others online, we are requiring that the EC provide a plaque stating the available short circuit from the utility with the date stamped on the plaque. The plaque should match the SCCAF report. Oh, that's a great lesson learned. Thanks, Tom. Todd, what is an acceptable means to create a SCCAF report when integrating with an existing substation? What information is actually needed to create the study when having a new substation? So let me just read this again. What is an acceptable means to create a SCCAF report when integrating with an existing sub? Yeah, so we do this quite a bit where I work. We have a lot of existing switch gear where we have a breaker that was spared, right? We have a lot of spare breakers that we're now going to feed out of and feed something else. The gear itself and the upstream requirements of the gear haven't changed, even though you're tying in to a distribution breaker and feeding something else. Your SCCAF report should start with, hopefully, the same model, meaning the same SKM model or Power Tools model that developed that report. Otherwise, the individual developing that report will have to develop the model further upstream just to make sure that their devices, their breakers, are properly coordinated for the short circuit available fault current at that breaker. So we should always be looking to not just at our scope, right? We shouldn't walk into a project with our blinders on, but looking at the full gear. Do the mains and the ties have arc flash labels, right? That's the first clue if a SCCAF report was developed. If not, it's a great question to ask the owner or the contractor or even the engineer of record of expanding the scope to include all of those devices. So what information? And so the second part of his question was, what information is actually needed to create the study when having a new board, right? So you're going to have to get utility information as far as their available short circuit fault from their incoming line. The contractor, the electrical contractor, is going to have to provide the cable lengths of all of their feeders to the individual developing the study, because they need to put that into the, I don't think I have a one line in here. I do not, but I think we do talk about the feeder lengths on this study. No, I don't see it. But on the one line that goes along with this SCCAF report, it's going to look very much like the project one line. It's going to have a device for the breaker. It's going to have the cable. It's going to have another device, and it's going to have the gear. Those cable links are required, and the contractor, the electrical contractor, is going to be required to provide those. A lot of times using like a BIM Revit model, they can pull the preliminary links so that the vendor can start to develop that study early. And this plays into the point of having a preliminary study at a factory or at an integrator such that you can get some of that information. If the project's BIM and Revit model, they can start to gather what those links are, within a few feet. And then as the EC takes over that model and starts to actually develop their bill of material for cable purchasing, now those numbers get refined and validated. The ETAP model or the SKM model then updated to reflect the actual available fault current at those devices. Great questions, guys. All right, let me scroll up in my window here. Yeah, so you need the feeder links, you need the utility information. You also need, and I think we've hit on this already, the actual breaker or relay model numbers. So if I jump back into this table here, right? So you're looking for the information for that actual overcurrent protection device, the model number, the rating, frame rating, the plug rating of the breakers. Let's see, I don't think this one has it here. Nope. But this is the report. This tells you what the settings are for the time. So yeah, so you need all the equipment information, cable links, utility information, and then they can develop their SCCAF report. All right, Tom says, another note is that the SCCAF report many times has an incorrect trip unit for the breaker. Yep, completely agree. In other words, the breaker trip unit installed does not match the breaker trip unit that was used. The SCCAF report verify the trip unit and all the required. Yeah, exactly. Yeah, completely agree, right? And sometimes it can be off by just a couple letters when it comes to the model number. And the reason that's important, and I'm going to come back to this table here, let me draw on it, is you're going to be given in this table, and I should have probably picked a different image with breakers. You're going to be given a range or a setting that you need to apply, and that's going to be in this area here. For a breaker, it might say long time function A, right? And then of that function, it's going to have a time band, and maybe that band is A or 1. And then the short circuit's can be based on your initial long time band or a function of the trip unit. A lot of times you might see on your one line diagram an 800 amp frame breaker with a 400 amp trip unit, right? So you have an 800 AF followed by an 800 AS, 800 amp sensor, or 800 AP amp plug. And what that's telling you, and what Tom's highlighting here is that you'll get a breaker. And a lot of owners do this for assets, right? They don't want to have an 800 breaker, an 800 breaker, and a 400 amp breaker. Give them all the same size breaker. It helps them move breakers in and out. But what they'll then do is they'll change the plug rating or the device sensor rating so that they can make that a fully rated breaker, right? 800 amp frame, 800 amp trip, or 800 amp frame, 400 amp trip. You can also do the same thing with an 800 amp frame breaker by dialing down those settings. So if you wanted to trip at 400 amps, you would change that long time value to whatever the value is for that breaker, 0.5. And then your short circuit, or excuse me, your short time and instantaneous are then a function thereof of that long time current. Your ground fault, if it's LSIG, your ground fault will be based on the frame rating of that breaker, and it also has its own time band. So when you're looking at validating your trip units and your breaker frame ratings, you want to validate that the bands and the settings available are actually what's on that trip unit or that sensor. Great question, Tom. All right, Kurt, can you discuss the NEC requirements for a fully coordinated system, emergency side, and how difficult this is to achieve below 0.1 seconds? Have you dealt with this as the CxA when the SCCAF report shows a lack of coordination in this region? Whew, I cannot, Kurt. That is a little bit above me. Sorry, I appreciate the question on that. I'm going to have to screenshot that one and go back in and dive into that. Let me read that again. Discuss the NEC requirements for a fully coordinated system, emergency side, and how difficult this is to achieve below 0.1 seconds. I would encourage Kurt, if you want to come off mute, we can have a dialogue and discussion about this. This sounds like an interesting topic that you've run into. I'm assuming this probably has something to do with the generator breaker or perhaps the generator ratings that you're seeing.
Yeah, can you hear me?
Yeah. Hey, Kurt, you're good to go.
Yeah, this comes up quite a bit, especially, and we do a lot of healthcare design.
Okay.
And what's odd in the NEC is Article 517 applies to healthcare, and it specifically allows for a lack of coordination below 0.1 second in 517.32, I think. It's weird, but if you go in the if you don't have a healthcare project not subject to 517, you're bound to the requirements, I think are in section 700 or 701, where you have to have a fully coordinated system, which means you can't have any lack of coordination in that region. And for anybody who's done a lot of SCCAF reports, you know it's really difficult to achieve, and these down in those really short time ranges, and sometimes you just have to live with it. But we've been wrestling now with some of the local AHJs are now requiring it in California, and it's super difficult. If you got a new system, it might not be so bad as long as you have the control as the specifying engineer to specify all solid state adjustable trip breakers, and you can try to get control over that and achieve perfect coordination, let's call it. But when you're dealing with existing systems, it's almost impossible because you're going to have some device somewhere that you just can't adjust. It's either static trip or it's adjustable, but it only has limited adjustable capabilities, and it's become a big headache. Seems like there's a new wave of people, maybe fresh out of college, that are now working for the plan check authorities and these AHJs around the country, and they're just going by the book on everything. They don't really have the experience to know that some of these things you just can't do. But I run into it as as an engineer of record and as a CxA, because I do a lot of commissioning and preventative maintenance work, and it's just a giant headache for us. And we always get killed on the fees when you're sitting there chasing your tail sometimes, trying to figure out what you need to do, and having to go back to an owner and say, well, you got to spend another $50,000 to replace this other existing equipment, which they don't appreciate. But
so is OSHPD requiring this?
Well, OSHPD's actually easier to deal with because all their projects, you don't have to have that fully coordinated system below 0.1 second. But it's non-OSHPD projects like, city of San Francisco or San Diego or LA, where the AHJ is starting to ask for these things. They're actually starting to ask for the coordination studies and like they've never done before. So it's been largely, to a large degree, a lot of the design engineers or engineers of records have not been held accountable for these things. And even people in my own office, they who don't have as much experience, they're younger PEs, hadn't had as much experience, but it's been very, very difficult. And I don't know who got a hold of the code writing committee to put this requirement in there. I'm thinking some fuse manufacturers maybe. But I just don't know if anybody else, if you or anybody else on this call has had to deal with this stuff yet.
I mean, that's interesting you bring that up, because where I work at our factory, we don't even have emergency power systems. We just use our dual utility redundant loop, and that's, if it goes down, it goes down. So that's an interesting call out on the emergency side.
Yeah. Now in OSHPD, they require it they say, well, it's required on the emergency side, but you also have to make sure that the normal side on the transfer switches is fully coordinated, because it serves the emergency branches.
Right.
Which further complicates it even more. So it's crazy.
So we're looking at what increased capital costs to get devices that equal that on the normal side that are potentially never going to be used in such a case.
It's really jacking up the costs on these projects to go back and on an existing project and fix some of the things that are existing conditions for the design engineer. And you never anticipated those kinds of things. So
well, that's a great topic. I love that you bring a different side of this to the discussion that I haven't even thought about. That's awesome. Thanks, Kurt. Anybody else have any lessons learned or things that they've run into that they would like to highlight for the greater good, and see if anybody else has experienced that? This is the part I really love about ACG. We as CxAs and even engineers or balancers come together in a platform to learn from one another. We do these events through the education committee in an effort to try to offer something out there that isn't done, right? We try to do something to educate others, as well as to share some topics that can generate some conversation. So I really appreciate Kurt and Tom and others that have chimed in today. If anybody has anything else that they'd like to talk about, we do have about another 5 to 10 more minutes, maybe. And we have to turn it back over to Sam here at the end. Let me go back to arc flash labels here real quick. So arc flash labels obviously are going to tell you a lot of information about the safety working environment of that equipment, of that gear. I remember working on a project once that went through at least 4 or 5 different revisions of the study. And we as an owner were trying to get to the point where we could work under a temporary label during construction. So we were taking the worst case scenario and trying to apply that to the whole gear, so that when we're in the electrical vault, we treat the whole space as that one boundary and at the minimum, which was the maximum PPE requirements of that space. And what that did is that allowed us and the contractor to move forward with energization, right? So we were getting little plastic sleeves, putting them on gear, and then sliding in this temporary arc flash label so that we could do our energization. We felt that was better than nothing, which is sometimes what we get when we're in construction, is we don't even get the arc flash label for fear of it changing. And that's an expense and a burden to the contractor that they don't necessarily want to undertake. So that's one thing I'd like to leave us with on arc flash labels. So let's just look again at our scope. Even if you're not doing, electrical commissioning, you should be verifying that breakers have been set. Again, who's setting them? Ideally, it's the needed testing agent before they go to test their breaker or that device. And then after they test it, they should be applying their label that it's been tested and that it passed. You as the commissioning agent, before you turn over a project, should do a good breaker, or even we used to call it a breaker and a valve walkdown. We'd walk down the mechanical system and check our valves to make sure they're in the right position, normally open, normally closed. And we do the same with our breakers, which breakers are open and closed, and are the settings correct. We even went to the point of putting tamper tape over the plastic window so that those settings couldn't be changed. In this current factory I'm in, we turned on equipment to serve a manufacturing line, and we get nuisance trips. And we're finding that the study isn't properly coordinated. So the ME team, or the manufacturing engineer team, is actually going out there and adjusting the settings. So now we have to, revalidate our report and go back and do it again. So you have to play within the owner's requirements of what they need, but it would be a great service for you to walk away of an integrated systems test right before closeout, that you've walked down that system and that everything's properly coordinated. And we got a question here from Kurt. Arc flash labels, where do you stop requiring arc flash labels in a distribution system? I usually stop at the last panel in that circuit. So obviously the main incomer, the breakers, down past any distribution panels, transformers, and then down to the last panel. That's usually where we end. We don't go down to the last device or to the last motor. We'll just stop at the last panel in that system. Anyone else have anything that they've done differently, or maybe they stop a little higher, right? It's not usually necessarily needing to go all the way down. I think if we look at this table here, this is a good table where you're going to start to get a lot of these incident energies really low, boundaries really low. So your PPE requirements are always going to be the same. So when you're looking at distribution panels past like a 120 to a 8 volt panel board, they're really not going to change any differently. But that's just the minimum standard that we've applied. It's usually for the higher incident energy spaces where you're going to have a different cal rating. A lot of owners and their maintenance team, right? It comes down to the operations team. What engineering protocols are they going to put in place for working within that space, right? Are they going to do a closed transition switch operation and maintenance? Probably not, right? So that incident energy can be reduced if they properly plan their work for maintenance. Great question, Kurt. Anything else from anybody? We have about 5 to 6 more minutes. Okay, I'm gonna jump back over to this one here. Yeah, and it's just as important when you're just looking at mechanical equipment and doing your testing that you verify you're not going to have nuisance trips when you're testing, right? You're going to be increasing the load of that circuit when you're testing your devices. You don't want those breakers to constantly trip. So you want to make sure that that study has been done, and maybe that's a prerequisite to your functional testing, or it's something that's on your pre-functional checklist, that the SCCAF study has been submitted, approved, and settings have been applied, right? That's a great just catch-all statement that your team is aware of before you go into testing on the mechanical side. Anything else before we turn it back over to Sam and she wraps us up here for the day? So I do believe everyone will get an opportunity to get AIA credits for today. I think you might even get 3 credits. I think that's how many we get. So Sam can coordinate getting your AIA number. I think you have to take like a 10-question quiz at the end of this. And with that, Sam, I don't have any more questions. So I'm going to turn it back over to you.
Okay, that was great. Thank you so much, Derek. And thank you to everyone that contributed and had a great discussion and great comments. I am here to remind you about CX Energy. If you're interested in certification, Derek is a CXA. We had a couple CXAs online here. We have a pre-conference with a CXA workshop and exam. We also have the Energy Management Professional Certification Seminar exam. If none of that applies to you, we have golf also at the same time. Pre-conference, we had about 40 people, 30 to 40 people last year do a fun golf tournament. We're doing it again this year. There's 30 sessions on commissioning, energy management, building technology. And right there is a code for a 10% discount. So we hope to see you online and hope to see you for the next spotlight. And keep a lookout for your emails and you'll see what the next topic is. So thank you, everyone, and have a great rest of your Thursday. Thank you, Derek, again, once more.
Yeah, thank you, everyone. Kurt, Tom, everybody that called in. Really appreciate the feedback. And, you know, feel free to let ACG know how you thought today went so we can always make improvements. Thank you.
Thanks all.